when you have a cross tabulation, you have two nominal or ordinal variables, and you cross them and you fill out the values in each cell, and you're wondering, does this independent variable in the column make a difference, or more accurately, does it help us predict the dependent variable? We've learned how to do that by hand, but you can do that in SPSS as well. So we go to the Analyze tab, our old friend the Analyze tab here, and we actually go under Descriptive Statistics. So we've been moving here to the Compare Means, and we're going to go back to the Descriptive Statistics and to the Cross tabs, because when we go into this Cross tabs option, it lets us set up that cross tabulation, which can be used for descriptive statistics. We can look at it and see the difference between the categories of the independent variable within each category of the dependent variable. And we also have an option. We can just click a couple extra things, and it will compute p-values and a chi-square value off of that. So what you'll do here is, if the variables you're interested in are already nominal or ordinal, then you're set. A caution with this, though, if you have too many categories, no matter what kind of variable it is, it's kind of not really worth doing a crosstab. If you have 8 or 10 or 15 categories, even if it's nominal or ordinal, it may not be the best. It'll just be a little bit too busy. But what we could do is just pick a couple of nominal or ordinal variables here. So here we have preference in hiring blacks, should age, live with their children, so on and so on. So let's do how important is it to be born in America? Okay, and let's use this as our dependent variable. So we want to know if something predicts your one's opinion about how important it is to be born in America. So what might we use to predict that? Well, we could use sex and see if there's a difference between males and females in their opinions about how important it is to be born in America, and this ties into immigration. So as you can see here, we have a statistics button. We just click on that. And right here at the very top is chi-square. So that's what you've been doing. You know how to compute this by hand. And now SPSS will do it for you just like that. So if you go on, if you do an internship or go to graduate school or get a job doing some kind of statistical analysis and these kinds of descriptive statistics, then you're set. It's just a few clicks of a button to get this set up. You put your independent variable in the columns, your dependent in the rows, statistics chi-square, but we have to do one more thing. Can you think what this would be? We need to percentage the table. So we come here to cells. This is where we percentage the table. Right here in the cells button. If you click on that, then we need to decide if we're going to percentage the row, the column, or the cells. And what we want to do is percentage through the independent variable and read across the categories of the dependent. So we want to percentage the columns because that's where we put our independent variable. Our independent variable is in the columns, so we percentage the columns, and then we'll read through the rows. So hit continue, and then we hit OK right here. That's going to give us our outputs. It's going to give us a table and another little table that gives us the chi-squared information. So here you have at the top some overall information. You have 1,242 people in this analysis that answered both of these questions. And if we come down to the table now, we see this is the content of the table right here. So how many degrees of freedom do we have? Well, if we take out this column and this row, we have 1, 2, 3. Again, remember, this is a cover 1 trick. You could also do columns minus 1 times row minus 1. and that would get you the answer. So we have two columns, and 2 minus 1 is 1. And then we have 1, 2, 3, 4 rows, and 4 minus 1 is 3. So 3 times 1 is 3. So the cover 1 trick gives us the right answer in a hurry. And like I've said before, we usually don't have tables that are too much bigger than this. At most, maybe a 4x4, 5x5, or something at the very most. So now what do we have? We need to make sure these add up to 100%, and it looks like they do. This adds up to 100%. And now we can interpret across the categories of the dependent variable. So the chi-squared test is really saying, are these both 42.7 or are they different? Are these both 22.8 or are they different? Are these both 23.5 or are they different? Are these both 11 or are they different? You need to remember that we keep the information from the dependent variable because we want to know if the independent variable makes a difference. So we leave the 42.7% that say it's very important. We leave the 22.8 that say it's fairly important. What we're interested in is if these differ between the categories of the independent variable, if they differ from each other. So that's really what we're looking for. That's the null hypothesis. Is there a difference between the categories of the independent variable? And really we keep this, we leave the categories of the dependent variable as they are. This is still going to be 42.7%. Say it's very important to have been born in America. So that's kind of helpful. At first I don't get into that too much, just to kind of get you the main idea that we're looking for difference or same. But really that's more precisely what we're looking for. And if we come down here to the chi-square test, we can see that we have a value of 8.775. And with 3 degrees of freedom, that gives us two-sided significance of 0.032. So if we had an alpha level of 0.05, then this p-value will be less than that. And because p is low, we can reject the null hypothesis that there's no difference across the categories of the independent variable. There's no difference in this table. So this should get you all set up for your assignment. You'll use your own variables, or if you don't have nominal and ordinal variables, you can choose others that relate to your study. And I look forward to seeing your results.